Hello everyone, welcome to my YouTube channel. So today's topic is all about condensation polymerization. So let's get into the topic quickly. So when I talk about condensation polymerization, I want you to know some concepts so you could understand this polymerization in detail. So the first thing that you need to know is that in condensation polymerization, we basically take two or one molecules, both you can take. So in the current Addison polymerization, we just use one molecule, that would be any alkene or any double bonded molecule, but that would be just one. But in the case of condensation polymer, there are two monomers used or sometimes one. And in the case of condensation polymerization, you're always having a byproduct. Okay, so the byproduct would be coming with the polymer, so the byproducts would be most probably water or HCl or something like that. Okay, so now you would be understanding condensation polymer, but before that I want you to understand this concept. In condensation polymerization, you will be seeing like boxes like this, and then there would be some functional group written like this, and that's how it goes. So what is basically this boxes for? Okay, so I would be just explaining you what are these boxes for. So now consider I would be writing a molecule that would be used to make a polymer. Okay, so this here is a polymer. So the name of the polymer here is 1,6 diamino hexane. Okay, so now in this you see that there are two functional groups of amide present, that is this one and this one. Okay, and the rest that contains the carbon chain. So what happens that in condensation polymers you have to use two different monomers, and both of them would be such long, so it's not feasible to write such big molecules on paper. So what we have done is the ones which are not used in the reaction, or which does not take part in the reaction, we just consider this thing in the box. Okay, so the one which is unwanted, or you could say does not take part in the reaction, we consider them in a case or a box, and therefore this molecule could, instead of writing such a big molecule, it could be written as this. Okay, so the box represents that it contains the carbons inside that, and therefore this is what the representation of boxes. So whenever you would be having representation of boxes, there would be nothing but the carbon chains which would be present, that would not take part in the reaction. So in the reaction, this only this functional group which is there, that would take part in the reaction, and therefore they are shown outside. So now we would be seeing some reactions, what is happening in the case of condensation polymers. So we would be talking about the molecule here. We would be making a glucose molecule, and we'll see what can be done in this case. Alright, so this here I've taken two molecules of glucose, and they undergo condensation polymerization. So what is happening here is that since this is a condensation polymerization, the water molecule would be coming out in the form of H and OH. So just remember, whenever you're doing condensation polymer, the water would only come out in the form of H or OH. Like you could take H from one molecule and OH from the other, and vice versa. You could not take like in H2O form, so you could not take two H's from one molecule and one O from the other. It should be always taken in the form of H and OH. So in this we would be taking water in the form of H and OH. So you could take this, or you could also take the OH from your NH from your, whatever you feel. So the first byproduct that we'll get is water. So now if you remove water from this molecule, both the molecules which is there, this bond and this bond which would be there with the O would be empty, and therefore they will be forming bonds together like this. If you add the one more molecule of OH to this end, then of course the water molecule would be again coming from this end, and there would be a linkage, and same goes for you. So again, if you add one more molecule of OH on this end, again the water molecule would come out from you, and there would be a bond between this. So the overall, if you want to make the polymer for this would look something like this. okay, and you have to keep n here again, so to represent that this chain which is there, it's continuous with n number of repeating chains. Okay, so this here was a very simple example. In this we just use one monomer, but now you'll be seeing some examples in which you will be using more than one monomers. So these are two monos which I've taken here. Okay, so again the same process would happen. So the water would come out from this in the manner that is HNOH. So and they would bind together to form a specific bondage like this. So here, this is how the water would go out, and there would be this linkage which would be formed here. This linkage that you see here, it's between the C double bond O and NH. This type of linkage is called as amide linkage, and the polymer which would be having this linkage would be called as polyamide. Okay, so this whenever you see this type of linkage, you would be always called as amide linkage, and this type of linkage is present in proteins, that is your natural polymer, and nylon, that is your synthetic polymer. So now again there will be addition of, so this is monomer A and this is monomer B. So if you want to do further polymerization of this polymer, you would be adding the B molecule here. It should be always a different functional group. So if this is a functional group, we'll take the one which has different. So we'll take B polymer here and you will take A polymer here. So let's see what happens. So here I would be taking the B polymer again to show you how the polymerization process would continue. So again from here the water would be removed, and at this point I would be using the A monomer to make the polymer. So again the water from here would be coming, and the continuous chain that you would be seeing would be like this. So this is how it would be going. So here we have just drawn four molecules. Of course the polymerization would be going endless, therefore I have placed your n, and therefore you will be always seeing this linkage. It means an amide linkage. So you would be seeing one more type of condensation polymer in which you would be seeing a different linkage. So here you will be talking about one more example of condensation polymerization. So again here you will be having the water coming out. So here I have taken a dicarboxylic functional group, and here is a diol which you could see. So again the water would come out from here in the same manner because it's a condensation polymerization. So you will be getting a byproduct always. So this is how, if the water comes out, the O here which would be free now, and since there's nothing here to bind, so it binds with the molecule, and this is how the first linkage would be formed between these two. So whenever we have this type of linkage, we have always seen that whenever a carboxylic acid reacts with an alcohol, it forms ester. So this linkage here is an ester linkage, and the molecules which are formed using this are called as polyesters. Okay, so again when I want to continue the polymerization of this, I would be taking the B monomer here, and here I would be taking A monomer and seeing what would happen again. So here I would be just taking the A monomer to show you the further process of polymerization. So again the water which is there would come out from both these molecules, and same goes for this. So the water, always remember, it comes in the form of HNOH. Okay, just remember this rule, it's very important. So it comes out in the form of HNOH. So here if you write the continuous polymer for this, now it would be written as so this is how it represents. So this your groups represents the ester linkage, and the N represents the continuous chain which would be formed. in this polymer. Okay, so I hope this video would be helpful for you to understand condensation polymer. If you like my videos, please like and subscribe.